In today's class, we are going to look at IUPAC naming of organic compounds. Please, I would like you to pay close attention because I will be showing you trick on how to solve IUPAC naming of organic compound with ease. Remember that in our last class, we discussed about organic compounds with 1 carbon, 2 carbon, 3 carbon till 10 carbon. And I told you that organic compound with 1 carbon is called met. Organic compound with 2 carbons is called et. Organic compound with 3 carbons is called prop. Organic compound with 4 carbons is called but. Organic compound with 5 carbons is called pent. Organic compound with 6 carbons is called hes. Organic compound with 7 carbons is called hept. Organic compound with 8 carbons is called oct. Organic compound with 9 carbons is called non. Organic compound with 10 carbons is called dec. Remember, I also told you about organic compounds with single bonds. They are called alkane. Organic compounds with double bonds, they are called alkane. Organic compounds with triple bonds, they are called alkyne. Also, remember, I also talked to you about numbering lists. Here, I told you that numbering is based on the following priority list. We have the acid, we have the aldehyde, we have the ketone, we have the alcohol. Acid, aldehyde, ketone, and alcohol, they are the surface. We have the triple bond, we have the double bond, we have the single bond. Also, we have the group called the halogens. Halogens, we have it as the chlorine, bromine, fluorine, as the case may be. We also have the alkynes, the methyl, and the ethyl. All these are the prefix. Now, let us concentrate on the easy way to name organic compounds. Let us start with this simple example here. Now, the first thing you need to note is you number the organic compound. Numbering of the organic compound will enable you to know how many carbon that are found in that organic compound. Now, follow me as we do this. Now, the first thing is you are going to number this organic compound. And the numbering is going to follow forward direction and backward direction. So let us start by numbering it in forward direction. Now we have it as 1, 2. We have numbered it in forward direction. So let us go ahead and number it in backward direction. We have 1, 2. We have also numbered it in backward direction. Since we have 2 carbon in this organic compound, so the name is et. Here, look at it here. Because organic compound with 2 carbon is called et. So the parent name of this compound will start with et. So we write et. Then the second step is for you to check the bond in this organic compound. Now, looking at this compound, you will see that the bond we have here is single bond. Then, since it is single bond, it belongs to a group called alkanes. Alkanes. So what we are going to do now is we are going to take A and E from the group alkane and join it in the parent name X. So it becomes ethane. So we are going to add the A N E. So it becomes ethane. Also, we are going to check in this organic compound if there is any functional group. So, as you can see, there is no functional group in this organic compound. So, the name of this organic compound becomes ethane. Let us look at number 2 example. As we progress, you are going to enjoy the class. Good. Now, the first step here now is to number this organic compound in forward direction and in backward direction. So let us take it first in forward direction. So we have it 1, 2, 3. So let's take it in backward direction. We have it 1, 2, 3. Since we have 3 carbon in this organic compound, it is called prop. Because we know that organic compounds with 3 carbon is called prop. Therefore, the parent name of this organic compound will start with prop. So we write prop. The second step is we check for bonds. Which bond do we have in this organic compound? The bond we have in this organic compound, we have 2 bonds here. We have single bond and we have double bond. Now, let us look at the numbering based on the priority list. You can see that here, triple bond supersedes double bond, while double bond supersedes single bond. Now, since we have double bond and we have single bond, we are going to choose double bond because double bond supersedes single bond. And double bond belongs to organic compound called alkane. Therefore, we are going to take ENE from alkane and join it to the base or parent name prop. So it becomes propane. We join ENE. It becomes propane. Now, the third thing to do is to check for functional group. There is no, okay, we have here, we have double bond here. So this double bond is between carbon number 1 and carbon number 2. If you are numbering it in a forward direction. And this double bond here also is between carbon number 3 and carbon number 2 if you are numbering it in backward direction. Now remember, when we are talking about numbering, we always choose the lowest number possible. Here we have 1 and 2 and we have 3 and 2. So 1 and 2, they are smaller than 3 and 2. So between 1 and 2, 1 is smaller than 2. So we are going to choose number 1. So this double bond is attached to this carbon number 1. Therefore, we can also rewrite the name of this organic compound as, we can write it as prop. You put hyphen 1 hyphen N. So it becomes prop 1N. Prop 1N. So either propane or prop 1N is correct. Let us go ahead and look at another example. You are free to pause the video so that you will understand it very well. Good. Now, let us start by numbering this organic compound in forward and in backward direction. Then, in forward direction, we have it as 1, 2, 3, 4, 5. In backward direction, we have it as 1, 2, 3, 4, 5. Since we have identified 5 carbon in this organic compound, therefore the name starts with what? Pent. Pent. So let us go ahead and write pent as the parent name. Pent. All right, so let's also take another step, which is trying to find out the bond in this organic compound. Looking at this compound, you will find out that what we have here is only single bond. We have single bond here. So since we have single bond, it now belongs to the organic compound called alkanes. Alkanes. Therefore, we are going to take ANE from alkane and add it to pent. So it becomes pentane. ANE. It becomes pentane. We also check for the functional group. There is no functional group in this organic compound. Therefore, the name becomes pentane. Okay, let's go ahead. Look at this organic compound also. We are going to start by numbering it. 1, 2, 3, 4, 5. We have identified 5 carbon in this organic compound, and 5 carbon is called pent. So we write the parent or base name as pent. Then we check for the bond. The bond here belongs to organic compound called alkane because it is a single bond. Alkane. Then we are now going to take the ANE from alkane and join it to this pent. It becomes pentane. Because this organic compound is arranged in a cyclic manner. In a cyclic manner. So we call it cyclo. Cyclo. We call it what? Cyclo. Therefore, the name becomes cyclopentane. Cyclopentane. Let's check another example. We are going to start by numbering the organic compound to find out how many carbons we have. So let's go ahead. 1, 2, 3, 4, 5. That is in the forward direction. Let's check in backward direction. We have 1, 2, 3, 4, 5. Since we have identified 5 carbon, we call it pent. We call it pent. So we write pent. We write pent. Now let's go ahead and find out the bond that this organic compound has. If you look at it, you will see that it has a single bond, and that single bond belongs to organic compound called alkanes. Alkane. So we are going to take the ANE from alkane and join it to the pent. It becomes pentane. ANE, we have added it, it becomes pentane. Then let's check for any functional group. Is there any functional group in this organic compound? Yes, we have chlorine as a functional group in this organic compound. And this chlorine is attached to carbon number 4. Carbon number 4 and also carbon number 2. Carbon number 4, where you are numbering in a forward direction, and carbon number 2, where you are numbering in a backward direction. Remember that we always choose the lowest number. Therefore, we are going to choose number 2 in backward direction. Since this chlorine is attached to carbon number 2, we call it 2-chlorine. But because chlorine, just like I told you in the last class, chlorine, which is a halogen, is called chloro. When you are trying to name organic compound, it's called chloro. We also have the likes of bromine. It is also called bromo. We also have fluorine called fluoro. All these are called halogens. So since we have chlorine here, so we are going to call it chloro. And since this chlorine is attached to carbon number 2, since it is attached to carbon number 2, so it's going to be 2-chloro. 2-chloro. Then writing it with the pentane is now going to be 2, you put hyphen, chloro. 2-chloropentane. So that becomes the name of this organic compound. And please don't forget that when you are writing a number or a digit before alphabet, you have to separate it with a hyphen, just like we did here. 2, you put hyphen before you write the alphabet. So we call it 2-chloropentane. That becomes the name of this organic compound. Let's go ahead and look for other examples. All right, we are going to start by numbering this organic compound to find out how many carbon we have. Then we name it, and then we look out for the bonding. After that, we look out for the functional group. Then we name the compound. It is very simple. So let's go. Now let's number it in a forward direction. We have it as 1, 2, 3, 4, 5. Let's also number it in backward direction. We have it as 1, 2, 3, 4, 5. Since we have identified 5 carbon, it is called pent. Please always have that in mind. It is called what? Pent. 5 carbon, pent. Therefore, let us write pent out as the base or the parent name, pent. Since we have written that, let us find out the bond that is associated with this organic compound. The bond we have here is a single bond. And that single bond belongs to organic compound called alkanes. Here, alkanes. So we are going to take ANE from alkane and join it to the pent. It becomes pentane. It becomes what? Pentane. Now, let us go ahead and check out for the functional group. Let's go ahead and check out the functional group. Now here, we have functional groups. Here, we have the bromine, we have the chlorine. Now, since we have bromine and we have chlorine, remember, when you are trying to name it, B will come before C, because alphabetically, B comes before C. Now, let us check out for B. Where is bromine attached? Carbon number what is bromine attached? Now, let's look at in forward direction. In forward direction, you will see that bromine is attached to carbon number 3. Chlorine is attached to carbon number 4. And chlorine is also attached to carbon number 5. Then let's look at in backward direction. You will find out that bromine is attached to carbon number 3 and chlorine is attached to carbon number 2 and chlorine also is attached to carbon number 1. Therefore, we are going to choose the lowest number, which is 2, 3, and 1. 2, 3, and 1 is lower than 3, 4, and 5. So we are going to choose 3, 2, and 1, which is numbering in backward direction. Now, since bromine is attached to carbon number 3, we are going to have it as 3 bromo. Remember that bromine is bromo. So we're going to have it as 3 bromo. So let's write. We are not going to have it as 3. You put your hyphen, you write what? Bromo. 3 bromo. Then you put your hyphen. The first chlorine here is attached to carbon number 1. So we have it as 1, comma. The second chlorine here is attached to carbon number 2. So we write it as 2. Then we put hyphen. Because we have 2 chlorine in this carbon, in this organic compound, we are going to call it di. 2 chlorine, we are going to call it what? Dichloro. So because we have here 2 chlorine, we call it dichloro. So we have it as dichloro. So the name now becomes 3-bromo 1,2-dichloropentane. That becomes the name of this organic compound. 3-bromo 1,2-dichloropentane. Another example. Let us start by numbering to find out how many carbons we have in this organic compound. So let's go in forward direction. 1, 2, 3, 4, 5. In backward direction. 1, 2, 3, 4, 5. Since we have identified 5 carbon, it is called pent. We write as pent. Then let's check for the bond. We have single bond. We have single bond here. We have single bond. And single bond belongs to a group called alkane. So we are going to take ANE from alkane and join it to this pent. It becomes pentane. Then let's go ahead and check if there is any functional group in this organic compound. We have identified one functional group here called methyl. So this functional group here is called methyl. It's called methyl. It's called methyl. And this methyl is attached to carbon number 2 in forward direction and carbon number 4 in backward direction. Remember, we always go with the lowest numbering, which is 2. So it's not going to be 2-methyl pentane. So it's going to be 2-methyl pentane. This becomes the name of this organic compound. Okay, let's look at this. Let's start by numbering. 1, 2, 3, 4. This is numbering in forward direction. Then let's check out for backward direction. We have 1, 2, 3, 4. Since we have identified 4 carbon, it is called boots. 4 carbons is called boots. So we write boots, B-U-T. We check out for the bonds. What we have here is a single bond. And the single bond here belongs to a compound called alkane. So we are going to take the ANE in alkane and join it to the boot. It becomes butane. Since we have done that, let's now go ahead and check if there is any functional group. Is there any functional group in this organic compound? Yes. We have functional group here, methyl. We also have it here. So we have this functional group called methyl. And this methyl is attached to carbon number 2 in forward direction and carbon number 3 in forward direction, carbon number 2 in backward direction, and carbon number 3 in backward direction. Therefore, we have it as 2,3. And since we have 2-methyl, it's not going to be dimethyl. So we're not going to have it as 2, 3, then hyphen, dimethyl butane. 2,3-dimethyl butane becomes the name of this organic compound. 2,3-dimethyl butane. It is called di because we have two methyl functional group in this organic compound. We call it di. Okay, another example. All right, we are going to start by numbering. In forward direction, we have it 1, 2, 3, 4. In backward direction, we have it 1, 2, 3, 4. Since we have identified 4 carbon, it is called boots. So we write it as boots. We write it as boots. Now let's check out for the bonds. Here we have single bond and we have double bond. Remember, based on the priority list, double bond supersedes single bond. So we are going to concentrate on double bond. So double bond belongs to a group of organic compound called alkane. Therefore, we are going to take ENE from alkane and join it to this boot. So we are going to join it because what? Butane. But remember that this is not the real name of this organic compound. Let us finish up and you will see the real name. Now, let us check. This double bond is attached to carbon number 2 and carbon number 3, both in forward direction and in backward direction. Therefore, since we have carbon number 2 and carbon number 3, we will choose the lowest number, which is 2. So it's not going to be called boot 2N. Boot 2N becomes the real and appropriate name of this organic compound. Boot 2N. All right. Remember that the first thing is find out how many organic compounds, find out how many carbon. The second one is check out for the bonding. The third one, check out for functional group. These are easy way to name organic compound. Let's check another example. Okay. Let us take the numbering in forward direction. 1, 2, 3, 4, 5. In backward direction, 1, 2, 3, 4, 5. Since we have 5 carbon belongs to organic compound called pent. Then we are going to write pent. The second step is we check out for bonding. If you check in this organic compound, we have single bond and triple bond. Now here, triple bond supersedes single bond. So we are going to take the triple bond. And triple bond belongs to a group of organic compound called the alkyne. Alkyne. So we are going to take the YNE from alkyne, then and add it here. So we're going to add it here. YNE. So it is called pentyne, but this is not the appropriate name. So let us now find out the appropriate name for this organic compound. Now, we have this triple bond is between carbon number 2 and carbon number 3, carbon number 4 and carbon number 5 in forward direction. And this triple bond also is between carbon number 1, carbon number 2, carbon number 3 and carbon number 4 in backward direction. Therefore, we are going to choose the backward direction because the backward direction has the lowest numbering. Now, in the backward direction between 1 and 2, we are going to choose 1 because 1 is smaller than 2. So we are going to choose 1. So we write out first 1, then we write comma. Then between 3 and 4, 3 is lower than 4. We are going to choose 3. So we also write 3. Now, since we have 2 triple bond here, we have 2 triple bond here, 1, 2. It's going to be what? Die. It's going to be what? Die. So we have it as die. You see that now? So the name of this compound will now be pent 1 3 diene. Have you seen it now? Pent 1 3 diene. So you can still use this YNE. So this becomes the name of this organic compound. Pent 1 3 diene. Okay, let's go ahead. We'll start by numbering 1, 2, 3 in forward direction. 1, 2, 3 in backward direction. Okay. Now, since we have 3 carbon, it's going to be called prop. It's going to be called what? Prop. It's going to be called prop. So we are going to write out what? Prop. Then let's check for the bond. What we have here is what? A single bond. So that single bond belongs to organic compound called alkane. So we are going to take ANE from this alkane and put it here. It becomes propane. It becomes propane. ANE. So propane becomes the name of this organic compound. Okay. Let us start by numbering it in forward direction. We have 1, 2, 3. Then in backward direction, we have 1, 2, 3. Since we have identified 3 carbon, it is called prop. We write what? P-R-O-P, prop. Now let's check for the bond. The bond that is in this organic compound is single bond. So that single bond belongs to organic compound called alkane. We are going to take ANE from alkane and join it to prop. It becomes propan. Now let us check for the functional group. We have identified functional group here belonging to alcohol. A functional group belonging to alcohol. Now, alcohol, we are going to take OL from alcohol and replace this E with OL. So we now have it as propanol. Propanol. We are going to replace it with OL. We now have it as propanol. So simply removing E and adding OL. So it gives you propanol. Propanol is the correct name for this organic compound. Or we can also call this propan 1-ol. We can call it propan 1-ol. Why? Because this functional group belonging to alcohol is attached to carbon number 1 in backward direction. So 1-ol, 1-ol, 1 alcohol, 1 alcohol, because OH belongs to a functional group called alcohol. So, and this functional group OH is attached to carbon number 1, which is 1 alcohol. Is that understood? So that's why we have it propan 1-ol. So it is also correct, propan 1-ol or propanol. Let's take another example. Okay, so we simply number it to find out how many carbon we have. 1, 2, 3, 4. That is in forward direction. Backward direction we have 1, 2, 3, 4. We have identified 4 carbon, and 4 carbon is called boots. So we write boots. Then we'll check out for the bond. The bond there is a single bond, and single bond belongs to a group of compound called alkane. So we simply take ANE from alkane and add it here. It becomes butan. Butan. Then let's go ahead and check for the functional group. We have functional group belonging to alcohol and is attached to carbon number 2 and also carbon number 3. Carbon number 2 in backward direction and carbon number 2 in forward direction. So we take the lowest number, which is carbon number 2 in backward direction. So we are now going to replace E with OL because this is alcohol functional group. So it's not going to be but, that's butan, because this alcohol is attached to carbon number 2. So it's not going to be butan 2-ol. Butan 2-ol. Reason being that this alcohol functional group is attached to carbon number 2. So 2-ol. Remember that alcohol, we take the last 2 number, the last 2 alphabet, which is OL. all to replace it. So it's now going to be what? Butan 2-ol. Let's take another example. Okay, let's go ahead and number it in forward direction. 1, 2, 3, 4, 5. Let's also do same in backward direction. 1, 2, 3, 4, 5. Since we have identified 5 carbon, it is called pent. 5 carbon organic compound with 5 carbon is called pent. So we are going to write pent. So we check out quickly for the bonding. We have single bond belonging to alkane. We take ANE, we write it ANE, which is pentan. Then we check for functional group. There is functional group here. There is functional group here. So this functional group here belongs to aldehyde. Belongs to aldehyde or alkanal. It belongs to aldehyde. So we are going to take Al. We are going to replace E with Al. Alkanal or aldehyde. This is a functional group called aldehyde. So this functional group is called aldehyde. Or you can also call it alkanal. Alkanal. So we are now going to take Al and replace this E here with Al. So it's now going to be pentanal. So we replace this E with Al, which is now called pentanal. Pentanal is correct, or we can also call it pentan 1-al. Pentan 1-al. Why? Because this functional group here, aldehyde, is attached to carbon number 1 in backward direction. It is also attached to carbon number 5 in forward direction, but we are going to choose the lowest number, which is carbon number 1. So 1-al, 1 aldehyde, 1 alkanal. You understand? So it's now pentan 1-al, pentan 1-al, or pentanal. So either of these is correct. Pentanal or pentan 1-al. Let's proceed. Okay. Let's go ahead and number it. We have 1, 2, 3 in forward direction. We have 1, 2, 3 in backward direction. Since we have 3 carbon, it is called what? It is called prop. 3 is what? Prop. So we write prop. Then let's check for the bonds. We have identified single bonds, and that single bond belongs to organic compound called alkane. So we are going to take out ANE from alkane and add it. It becomes what? Propan. It becomes propan. It becomes propan. Now let's check if we are going to have or see any functional group here. Yes, we have seen functional group here, and this functional group here is called ketone. It's called ketone. So, and this ketone functional group is called ketone. So let's write, this is called ketone. It is called ketone. So we are going to take O-N-E and replace this E here with O-N-E. So it's not going to be propanone. So we are going to put O-N-E, so which is called propanone. So propanone becomes the name of this organic compound, propanone. Okay, here, let me clarify something here. Here, we are not going to consider these two by saying propan 2 on. No, we can't say propan 2 on because this ketone also retains its position. It must always be between 2 carbon. So this ketone must always be between 2 carbon, because if you take this ketone out here and put it in this carbon here, so it now changes and become aldehyde. Or even if you take it to this side, it becomes what? Aldehyde. So this is its original and the position it retains in organic compounds. So there is no need of adding 2. There is no need of saying propan 2 on. No. So you just call it propanone. Is that understood? Okay. Let's go ahead. Okay, let's look at this. We are going to number it. 1, 2, 3, 4, 5. Also in backward direction, let's number it. 1, 2, 3, 4, 5. Therefore, we have 5 carbon, which is called pent. So we write pent. We write pent. Then we check for the bonding. The bonding that exists here is what? Single bond belonging to alkane. So we are going to take out ANE and put it here. It becomes pentane. But pentane is really not the name of this compound. Let's find out the real name. Now let's check out for functional group. We have a functional group here belonging to acid. Belonging to acid. And this functional group here belongs to acid. So it belongs to acid. Acid functional group. So we are going to remove this E and replace it with OIC acid. That is oic acid. Oic acid. Then writing it out in full, it now becomes pentanoic acid. Pentanoic acid. It becomes what? Pentanoic acid. So pentanoic acid is the real name of this organic compound. Or you can also call it pentan 1 oic acid. It is also correct. Reason being that this functional group acid is attached to carbon number 1 in a backward direction. So we have it 1 oic acid. 1 oic acid. We are not going to choose 5 because 5 is bigger than 1. We always go for the lowest number, 1, which is 1 oic acid. Is that understood? Now, 1 oic acid. Is that understood? So having said that, I will allow you to solve this. Please solve this and put the answer in the comment section. And if this tutorial interests you, please share it with your friends, comment, and also subscribe to this channel. See you in the next class. Thank you.